Okay, friends, we're going to take a look at number 18 on the Goformative. Some of you were unable to be in class today for good reasons, so I thought I'd just take a time to show you what we were going to do so that our review time together wasn't lost. So just made a video, earlier videos on number 6 and 17, and now I'm going to look at number 18. And this can be kind of a tricky question for sure. Alrighty, so there's some common threads to related rates that some of you have made, and some of you are having trouble seeing. They feel different every time. And while the stories might be different, the concept is, and how we work through them is very, very similar. So the first step here in any of these problems is just to read it a number of times, noting that you're going to panic a little bit. You're just going to be unclear. And so that's where you need to push into 4D. You know 4D. You need to persevere. If you aren't able to be persistent, then you're not going to be able to be curious. You won't be creative. You won't notice and wonder, which is what we need to do. And that is the skill we are looking for. So let's get into this. Okay, so it says there's wheat being poured over a conveyor belt. So I'm going to do my best attempt at a conveyor belt. And I'm going to put the little things like this, and that thing is spinning, da 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 da, and there's wheat like this, and it's coming over the top, and it's making sort of a conical pile. Okay, so it's sort of like a cone shape on the ground, and it's getting bigger. Okay, so now what I need to do is sort of label it as best I can. It says that it's being poured out at the rate of change of the volume is 9 meters cubed per minute. Okay, so that would be an important piece. So there's the volume. Okay, I know it's about volume, and I know it's about volume because I see that little equation right there. It's literally given to us, and so you don't need to memorize these formulas. You do need to know how to use them, though. Okay, so there's my volume, and I know there's going to be a v prime involved. Okay, okay, which forms a conical pile, and in which the height is always 4 times radius. Oh, that's interesting. So here's my height right here. And here's my radius. I have not done a great job of making this to scale. And we're going to call my drawing here an estimation rather than a great representation. But for the sake of this drawing, I'm hoping that it'll be okay. So notice this. It says the height is always equal. The height is always equal to, that's a terrible H. Oh my goodness. I'm going to decline that phone call because you guys are more important than that problem. Okay, so here we go. So H, okay, so where were we? Oh, yeah. So 4H, this is a terror. Let's try that again. 4H equals, that's not true. The height is always 4 times the radius. So oh my goodness, rattled. Okay, H equals 4 times the radius. The height is always 4 times the radius. So that's a statement we can count on, okay? So where are we? So we might want to say that height equals 4 radius. That might be helpful, okay? I hope you recognize that there is an r prime, and that r prime would be getting bigger, and the height is also going to be bigger, growing. It says, how fast is the height rising when the height is 12 meters? Okay, so I think it's time to get some variables down here. So let's do that. So we're going to go v prime, and we know what v prime is. It's 9 meters cubed per minute. Okay, and then we're going to go r prime, and from the question it doesn't tell us anything about this. Okay, and then we're going to go h and h prime. And it does tell us, it is asking how is the rate of change of the height changing when h is 12. Okay, so they don't, that's what we know, but we can only put 12 in after we've taken the derivative. Okay, so this is a spot where many people, and my friend in the hallway today, my friend on the stairs, this is the challenge right here. I'm trusting at this point that you can draw this picture and that you can write down the equation. The hard part right now, and the real life application right now, is when we look at a problem, whether it be real or abstract, whether it be in school or out of school, whether it be personal or athletic or musical or whatever it is, what we have to be able to do is use noticing and wondering to determine what's needed, And this is really tricky, and you only get good at it by persisting. 4D and 4A go together. Okay, so it's also, are you open to a variety of ways? And we talk about that all the time. And what I mean by that is we always say step 1 on a problem is to panic, step 2 is to let it be, and step 3 is I bet there's a lot of ways. And that's what we need to get better at, okay? And that only happens by putting in time. So do you notice here that we don't know anything about R? Or we don't have the information like we do here. Plus, we're looking for H prime. So when I look at this equation right here, I need to start thinking, wait a second, I have 2 unknowns, and this, oh gosh. And these are my 3 little beautiful cuties that you guys can see there. How do I get back to what we're doing? Okay. So we don't know anything about R, and we do know stuff about H. So this should be a sign at this point that you're like, okay, we got to find a way to represent R, or we need to get rid of R. And when we look over here, a very important distinction was made, and that's that the height equals 4R. So what I'm going to do is I'm going to get curious and think, is there a way I could represent this in a way that would be helpful over here? Since I don't know anything about R, I'm going to write H in terms of, I'm going to write R in terms of H. So R would equal H divided by 4. So if H equals 4R, then R equals H divided by 4. And you might say, I wouldn't think to do that. And the only question I can ask you is, how much time are you putting into noticing and wondering? Because that's what it takes. And it's not one that should be like super obvious. If it was obvious, we wouldn't be giving this question. And if it was obvious, then it wouldn't be a problem. And this is problem solving. So what I'm going to do is I'm going to replace R. I'm going to replace R with H over 4. Okay, and I can't tell you how many people, even at this level here, really struggle with what's next. So I want you to pause the video and see if you... Okay, friends, I am back. A couple phone calls came in that I needed to take, and here we go. So let's just look at what we have. So this part right here, people will still have trouble with it, and people are always looking for steps. Great, but let's think about it. What are our options here? Is this a derivative? It's not a derivative yet, and the question is saying, how is the height changing with respect to time when h is a particular value? If we take the derivative right now, you need to realize that there's 2 different functions being multiplied together, f and g. Do you want to do the product rule? Please say no. Please say, hey, haven't we always tried to reduce before we move forward in a problem? And the answer is yes. Always reduce, always, whenever you can. So h squared is h squared, and 4 squared is 16 times by h. And then what we're going to do is we're going to go 1/3 pi. So that we're going to have a fraction here. We're going to have h cubed on top, because h squared times h is h cubed. We're going to have pi on top. Pi is not a variable. 3 times 16 is 48. So here is our formula. So we've whittled it all the way down from a picture to our variables, and then we paused and we got curious. This was a really hard move right in here, translating R to H over 4. And you're going to say, how did you know to do that? The reason what we know to do is we didn't have enough information. This should be all of our attention should be on R and H and this cute little statement right here. Is there anything we can do right there? So that's what should be going, kind of floating around your mind. How can we connect that? How can we make this more simple? At this point here, you're going to take the derivative. So dv dt, which I'm going to call v prime, is going to be pi over 48. That's just the coefficient, which is then going to be multiplied by 3h squared h prime. Okay, and now we're going to isolate for h prime, and I'm going to trust that you know how to do that. We know what v prime is. It's right here. It's 9. So let me get this view. The color purple has not been used enough today. So the purple 9 goes there. We know that 12, and we can put 12 in right now because we've taken the derivative, and we're interested in how is the height's rate of change. What is the height's rate of change when h is 12? So there you go. We're going to rearrange all that, solve, and call it a day. So I do hope that that was helpful. We'll see you around the school. Come by for a visit if any of this is not landing for you.